In this tutorial, I'm going to show you the inner workings of the Python interpreter from source code to what you see on the screen. Hey, it's Chris with A to C Python Academy with more tips and tutorials to help you be the budding Python developer we both know you can be. Thanks for being here, and if you haven't already, tap that subscribe button and don't forget to hit the notification bell so you don't miss a new tutorial. So in our last video, we talked about how the software communicates with your computer and how important the interaction creates the baseline for the Python interpreter. If you have not seen the video or are interested in revisiting that video, you can click on the link in the top right corner and check it out. That video will help you understand the relationship between binary, machine code, memory, and processors when it comes to understanding how Python is run. But today we're going to talk about how the Python interpreter works and how you get from the source code you write to the program you see executed on your computer screen. Let's get started. Now, in my terminal right here, I have Python 3 and the source file hello_YouTube_subs.py. Now, when I run that file at the terminal prompt, you need to understand what is considered to be the interpreter in this command. Python 3 is the Python program. That is your software. That is the Python interpreter. It is already written in binary. It is already written in ones and zeros. It's already written in machine code. That means that your processor can immediately understand what that program wants it to do. But what is not in binary, what is not in ones and zeros, and what is not in machine code is your source code. Your source code, which is hello_YouTube_subs.py. That is written in a high-level language that me and you can only understand. Again, remember from the last video, you have to understand that because this is not in a low-level language, a machine code language, your processor doesn't know what it is. It is just a text file sitting on your hard drive. It doesn't care what it is. It can't do anything with it. It can't read it. It needs to have it in a language, a low-level language, for it to understand exactly what is going on. In memory, your Python interpreter is broken up into 5 sections. So initially you have your source code, which is the hello_YouTube_subs.py, and there's 5 processes, if you will, that it has to go through before your source code becomes machine code that can be executable on your processor. It has to go through the lexer, the parser, the compiler, bytecode, and then finally through the Python virtual machine, which then executes it on the processor, and then you see what's on the screen. Now, let's go into a little bit more detail as to exactly what's happening with each one of these sections. The first step in the process is that your source code, your hello_YouTube_subs.py, and my arrow is going in the wrong direction. It should actually be going in this direction here. That's okay. This source code is passed to a process called lexing. Now, the lexer manually disassembles the line of code and creates tokens. The tokens are then sent to the second step in the process called the parser. The parser uses the tokens received from the lexer and creates a formation called an abstract syntax tree. The AST then creates a relationship between the AST and the tokens. From there, the parser sends that AST to the compiler, which turns that AST code into code objects. Now, the compiler then creates from those code objects a file format called bytecode. Now, this bytecode is also known as an intermediate language code, or an ILC, and it has an extension of .pyc. But when you open up one of these files, you could see some of the source code that you created, but most of it is garbled and it's unreadable because it's mostly in bytecode. It's not necessarily machine code yet, and it's not readable by us. So at this point in the process where it's now bytecode, your processor can understand it. So that .pyc file is directly related to the Python virtual machine so that it can actually take it and read that file and understand what its next steps are supposed to be. In relation to the Python virtual machine, it is written in C language, which is why it can be compiled into a machine language and executed by the processor. No one else can read or decipher and use that .pyc file other than the Python virtual machine. Now let's talk a little bit about the compiler. In normal circumstances, a compiler usually operates outside of the interpreter, which is why a lot of programming languages are faster than Python, because the compiling happens outside of the actual running of the software. So by the time the software runs, there's no compiling that needs to be done, it just executes. But in Python, the compiler is located inside of the Python interpreter. So at runtime, it's compiling. And what that does is it actually slows down the process of your Python source code executing. Once the Python virtual machine has received the bytecode, the .pyc file, it basically emulates the job of the processor. It turns that .pyc bytecode into machine code. Your source code is now in machine code. This machine code can now be understood by the processor, and now the processor can take that and execute it, output it on the screen, send it to a piece of hardware, execute a piece of software. Whatever the instructions are for it to do, it can now do it because it is now in machine code. Well, that's it for this video. I hope you found value in it. And if you want more free of charge Python tips, tricks, and tutorials, hit the subscribe button so you don't miss a thing. Thanks for watching, and I'll see you in next week's class.